All right, everybody, we're going to try to do some video today. You know how good I am at technology, so you might have to hang tight just a little bit. Okay, so what I'd like you to do is I'd like you to just start by reading this, and then I want you to identify what types of energy box A and box B would have initially and finally. So pause the video and do that now. All right, so we're back. And you see we have our two masses. We have our mass A here, and this is our mass B here, right? So this is our mass B. Maybe I'll make that bigger. Try that again, B. Yep. And they're released from rest. So we want to find the speed of box B. And honestly, it's the speed of both of the boxes, isn't it? After box B has fallen 0.5 meters. So a couple of key pieces of information. The surface is frictionless, so that means we will not have dissipated energy. That's important for us to recognize. Let's also draw in some context. So let's go ahead and draw in and locate our 0 right here. And so then we'll put our initial position for box B right here of 0.5 meters. And it's super hard to draw on this, so you guys are going to have to kind of make this work. Y is equal to 0 meters. Maybe my finger will just work better. We might try that. Okay. So I chose this problem because it's a little bit more of a complicated system, right? Because we have two objects. So let's go ahead and define our system. So some things that we always put in our system, we know we always put in the Earth in our system. So our Earth is in our system. Earth is in our system. I'm just going to use E to symbolize it because I don't have enough room to write. We are also going to have block A, block B. I would also include like the rope and the pulley and all those different things in the system. So we really indeed are taking this whole thing to be our system. Okay. Initially we have no kinetic energy because it begins at rest. So initially we have no kinetic energy. And there's no spring involved anywhere in our system, so we also do not have elastic potential energy. And so really the only type of energy the system of block A and B has is going to be that initial gravitational potential energy, okay? So I'm going to go ahead and draw that in. Do I know how big? No, I really don't know. And honestly, I really don't care. What's important is the total amount of energy staying the same between the initial and the final, as long as no work is being done. All right, speaking of work, let's make sure we understand why there is no work done in this situation. So I'd like you to pause the video again. I would like you to turn to your next door neighbor, and I want you to answer the question, how do you know that no work is done on this system? Okay, we're back, and we know that no work is done on this system because there is no external force on the system. So the only forces that are acting on the system are inside of this system boundary, right? Plus the Earth, right? We included the Earth in our system, and we did that purposefully because the gravitational potential energy here is associated with that energy. And so there are no other forces that are acting on the system that are outside of the system. Okay, and so after a certain amount of time, the block B has fallen. Block A is also moved, right, and accelerated along the ramp. So we are going to have some kinetic energy for sure. So yes, we're going to have kinetic energy. We have said that our 0 position for block B is going to be here at that 0. So we're going to say we will have no gravitational potential energy. Notice we're saying block A doesn't have any gravitational potential energy because it doesn't change, right? It doesn't change from the initial to the final, so we can just kind of ignore it. And we also have no elastic potential energy. And we have no elastic potential energy because there's no spring in the system. All right, so this conservation of energy equation is really pretty easy to set up, right? We start with our gravitational potential energy plus our work, which in this case is 0, we have no work, is going to be equal to our kinetic energy. All right, I am going to try to use a little bit of a thicker pen to see if that's going to help me a little bit. Okay, so let's see if I can make that a little bit neater. Let's try. Just kidding. See, I told you this was going to be an adventure, you guys. All right, EG plus 0. And I think on your sheet, we actually call this U for potential energy, which is fine, is going to be equal to my kinetic energy. And I'm going to call that one final, right? And I'm going to call this one initial. We want to differentiate between initial and final because of our initial situation and our final. It will help us when we do our solving, right, of our work. Okay, so now we're going to put in our equation. So our gravitational potential energy is mg times r, and I believe on your equation sheet it's called like delta y. And then in our kinetic energy, we'll go 1/2 mv squared. Now, something we have to be really careful about in this particular case is our masses, because initially only block B has that gravitational potential energy. So this right here is going to be mass B, where finally both block A and block B are in motion, right? So this is going to be both masses, right? So this is both masses. So those don't cancel out because those two different masses are different. Again, block A does not change in potential energy, so we don't include it in our LOL diagram, but block B's does change. So that's why we include that. All right, so if we take a look back at what we want to know and understand is the box's final speed. So we are going to want to identify this guy right here, right? We want to identify that guy. That's going to give us the velocity of both, right? Both block A and block B. So what I'd like you to do right now is I'd like you to pause the video. I'd like you to put in your values, and I'd like you to solve for your velocity. All right, and we are back, and our final velocity of block A and block B will be 1.56 meters per second. If you did not get that answer, I'm going to guess it's because of the mass values that you used. Please make sure that you are using, for this first one, just the mass of block B, because that's the gravitational potential energy that's changed. We know our height of 0.5 meters. We use 9.8, just the regular old number, 9.8. We don't need to put any negative there. And then this mass right here is going to be both block A and B together, so that will be a total of 16 kilograms. All right, good luck today. Work hard.